Okay, chapter 3.1 is on the quadratic functions. Here are our objectives. So the standard form of a quadratic function. The quadratic function f of x equals to a times parentheses x minus h, whole thing squared plus k, where a does not equal 0, is in standard form. The graph of f is a parabola whose vertex is the point h, k. So the vertex is the point h, k. The parabola is symmetric with respect to the line x equals h. If a is greater than 0, the parabola opens upward. And if a is less than 0, the parabola opens downward. To graph a quadratic function in standard form, the first thing you want to do is determine whether the graph parabola opens up or down. So if a is positive, then it opens upward. If a is negative, then it opens downward. Determine the vertex of the parabola. The vertex is going to be the point h, k. Now let me draw your attention to the form. The standard form has a minus sign, so you're subtracting inside the parentheses, and you are adding on the outside. That's very important when doing the vertex. You're subtracting inside the parentheses and adding on the outside, and your vertex would be h, k. And then step 3 says find any x-intercept by solving for f of x equals 0. The function's real zeros are the x-intercepts. So how do you find x-intercepts? Set f of x equal to 0 and solve for x. And then step 4 would be find the y-intercept by computing f of 0. When it says f of 0, you're going to replace x with 0. So replace x with 0 and just solve. And then the last, step 5, would be plot the intercepts, the vertex, and additional points if necessary. Connect these points with a smooth curve that is shaped like a bowl or an inverted bowl. So this is how a parabola should look. It's shaped like a bowl or an inverted bowl. All right, let's go in our books to page 343. We're going to start by looking at number 1. It says the graph of a quadratic function is given. Write the function's equation, selecting from the following. So this is number 1. Okay, so we look at number 1, and the things we want to look for, you want to find the vertex. So we are looking at the graph, find the vertex, and you need to know, does it open up or does it open down? Okay, so the vertex is going to be the point. So let me draw a picture. If I had a bowl shape, then my vertex is the lowest point. Here's the point where it turns around. So it's like it's decreasing, then all of a sudden it reaches the vertex and it starts increasing. If it was an inverted bowl, the vertex would be up here. So again, is where it turns around. I'm increasing, then all of a sudden I just start falling. So the vertex in number 1 is going to be at the point 1, 1, 1, 1. And does it open up or does it open down? Well, it opens up, which means the leading coefficient is positive. All right, so out of our choices, F, G, H, and J, let's figure out which one has the correct vertex. Now, our function should look like f of x equals a times parentheses x minus h. So the h goes here, whole thing squared, plus k. So h in this problem is 1, so we're going to put the 1 there. And k in this problem is 1. And then this a, I don't know exactly what the number is, but I know it's positive, and that's good enough. So out of the f, g, h, and j, which ones match up? It looks like it's going to be h. So number 1 is h of x. H of x equals x minus 1 whole thing squared plus 1. So in this case, a was equal to 1. Okay. Now, when I wrote f of x, I didn't mean the problem in your book. I'm sorry, I didn't mean f of x in your book. I should call this something else. Let me call this, I'm looking for a letter they haven't used yet. Let's call it k of x. It's just a standard form. Remember, k of x, f of x, g of x, it just means function. All right, let's move on down to number 3. Number 3. Oh, yes, number 3. So this time, we need to figure out, well, what is the vertex? Does it open up or does it open down? Well, the vertex is at the point 1, comma, negative 1. And it opens up, which means a is positive. So if we had to put it in standard form, it should have a times parentheses x minus 1 plus negative 1. Because remember, you have a minus sign inside the parentheses and a plus sign on the outside. So really it looks like a times parentheses x minus 1 whole thing squared minus 1. And for now, we don't know what the a is, but we can try to match it up. Out of all of our choices, we should agree with j, right? So j of x. So this answer is equal to j of x. So j of x was x minus 1 whole thing squared minus 1. All right, now let's move over down to number 11. So number 11, the instructions say, find the coordinates of the vertex for the parabola defined by the given quadratic function. So f of x is equal to negative 2 parentheses x plus 1 whole thing squared plus 5. All right, so they told us to find the vertex. Well, remember, standard form is written as a times parentheses x minus h squared plus k. Remember how we said we have to have a minus sign inside of your parentheses and the addition sign in front of k. So if I look at this, the addition sign, it matches up, but the minus sign doesn't. So we need to rewrite this so we have a minus sign. So when you rewrite it, you still have the negative 2 parentheses x, but now it's minus. So you introduce a minus sign, which means your 1 has to be negative. Whole thing squared plus 5. So now you have your minus sign and your plus sign in the correct place. And h is the piece that follows the minus sign. And k is the piece that follows the plus sign. So your vertex is at the point negative 1, comma 5. All right, let's move on down to number 17. And it says, use the vertex and the intercepts to sketch the graph of each quadratic function. Give the equation of the parabola's axis of symmetry. Use the graph that determines the function's domain and range. So this time we have f of x equal to x, parentheses, x minus 4, whole thing squared, minus 1. Well, let's go ahead and find our vertex. So let's find our vertex. And you do so by making sure it's in the right form. Well, we have a minus sign on the outside, minus sign inside the parentheses, so that's good to go. but this should be a plus sign. So let's rewrite this. So this becomes x minus 4 whole thing squared plus negative 1. Now we have the plus sign. So who follows the minus sign inside the parentheses? 4. And who follows the plus sign on the outside? Negative 1. So the vertex is at the point 4, comma, negative 1. Okay, let's find our x-intercepts. To find your x-intercepts, as I said, you replace f of x with 0 and solve for x. So replace f of x with 0 and solve for x. So we have x minus 4 whole thing squared minus 1 equals 0. And all I did was put 0 on the right side instead of the left side, which is fine. And then let's solve for x. So you're going to add 1 on both sides. And you get x minus 4 whole thing squared equals 1. Well, the x is inside my parentheses, which means I need to get rid of this square. You get rid of a square by taking the square root. So now you have x minus 4 equals the square root of 1. And it is plus or minus the square root of 1. You have two answers. And, you know, the square root of 1 is just 1. So now we have x minus 4 equals plus or minus 1. Add 4 on both sides. And you get x equals 4 plus 1 as well as 4 minus 1. So your x-intercepts are at the point going to be 5 and 3. So those are the points 5, 0 and 3, 0. Alright, so we have our vertex in the x-intercepts. Let's find the y-intercepts. The y-intercept, you just replace x with 0. So where you see an x, make it 0. So now you have f of 0, which is just going to be our y-intercept, is equal to 0 minus 4 whole thing squared minus 1, which turns out to be 15. So your y-intercept is at 0, 15. Your axis of symmetry. So your axis of symmetry is at the line x equals h. Okay, so h was equal to 4. So your axis of symmetry is going to be x equals 4. Okay, and then the function's domain and range. Well, first of all, the domain is the x values, and like before with the x values or your domain, you look for the denominator and square roots. We have neither here, so the domain is all real numbers, negative infinity to infinity, and the range is actually comes from the vertex and whether the parabola opens up or it opens down. Now this one, the number out front is a 1. It is positive, which means this parabola opens up. So it should have a shape like this. Okay, so its vertex is right here. So that 4, negative 1 is down here. So the range deals with the y value. So what's the smallest that this graph will be? Negative 1. And you include it, so you have a bracket, negative 1. And where does it go to? It goes off to infinity, way up here. So it's going to infinity. Now graphing this, I say graph it with your calculator to verify that these points match up. Your vertex, your x-intercept, your y-intercepts, and your domain and range. Alright, so now let's talk about the vertex of the parabolas of a parabola whose equation is equal to the following. This is the quadratic form of your parabola or your quadratic function. So it says f of x equals ax squared plus bx plus c. The parabola's vertex is at the point. Now remember your points are written x, y. So they're telling you that the x point is going to be negative b over 2a. The b and the a are the coefficients. The b is the coefficient on the x, so the number out front of the x term, and the a is the coefficient out front of the x squared term. So that is how you find the x coordinate. Then once you have it, you take this answer, and you plug it back into your function to get your y coordinate. So the y-coordinate is found by substituting the x-coordinate into the parabola's equation and evaluating the function at this value of x. To graph f of x equals to ax squared plus bx plus c, well, just like before, the first thing you want to do is determine whether the parabola opens up or if it opens down. If a is positive, then it opens up and it has a bowl shape. If a is negative, it opens down and it has an inverted bowl shape. The second step is to determine the vertex. And like they said before, find the x by doing negative b divided by 2a. Once you have the x-coordinate, plug it back into the function to find the y. Step 3, find any x-intercept by solving f of x equals 0. Step 4, find the y-intercept by computing f of 0. And then step 5 will be to plot and connect the points and use additional points if you need to. Alright, let's go in our books to page 343. We're going to start by looking at number 6. And it says, the graph of a quadratic function is given. Write the function's equation, selecting from the following. So, just like before, we need to know the vertex and whether it opens up or if it opens down. Well, by looking at it, we know it opens up. And the vertex, so this graph has the following look to it. It's a bowl shape, which means the vertex is the lowest spot. So your vertex is down here. So this one has a vertex of -1, 0. So the standard form of it should be a times x minus, because remember the minus sign inside the parentheses, -1 whole thing squared plus 0. So we clean this up the same as saying a times x plus 1 whole thing squared plus 0. For this problem, let's assume that a is equal to 1. So let's assume a is equal to 1. So now we have x plus 1 whole thing squared. I don't need the plus 0. We multiply this out. We get x squared plus 2x plus 1. And then let's see who matches up with it. It would be f of x. So f of x is the x squared plus 2x plus 1. So the function number 6 is equal to f. Alright, let's look at number 8. So number 8, same problem. We need to determine the equation of the quadratic function. So first we need to know the vertex, and we need to know if it opens up or if it opens down. The vertex and if it opens up or if it opens down. Well, we know it opens down by looking at it, which means our leading coefficient is going to be negative, and the vertex is going to be at the point 0, -1. Now, if we look at all of our choices, F, G, H, and J, only one of them has the leading coefficient, or the A, negative, which means it opens down. So this answer, by process of elimination, is just j of x equals -x squared minus 1. And that's all because of this negative sign. We know it opens down. Alright, number 15. Well, it says, find the coordinates of the vertex for the parabola defined by the given quadratic function. So we have f of x equal to -x squared minus 2x plus 8. So let's find the vertex. So to find the vertex, the first thing you want to do is figure out what's your A, your B, and your C. So A is the number in front of the x squared, so it's just -1. B is the number in front of the x, so it's -2. And C is a number by himself, so it's 8. Now, using that, let's find x. So x is going to be equal to -b over 2a. So that's -2. Be careful with double negatives. Divided by 2 times -1, which is going to come out to be -1. So the x-coordinate is -1. And then the third thing would be to take this value and plug it back into your function. So y is going to be equal to -1 squared, and again, be careful with negatives, minus 2 times -1 plus 8. So y is -1 plus 2 plus 8, which is 9. So we have a vertex at -1, 9. Okay, the number 27. It says use the vertex and the x-intercept. Use the vertex and the intercepts to sketch the graph of each quadratic function. Give the equation of the parabola's axis of symmetry. Use the graph to determine the function's domain and range. Number 27. We have f of x equals x squared minus 2x minus 3. So first of all, let's start by finding the vertex. Which means we need to know what's the a, the b, and the c. So a is equal to 1, b is equal to -2, and c is equal to -3. So x is going to be -2 over 2 times 1, which is just 1. And then the y comes from taking the x and plugging it back in. So that's 1 squared minus 2 times 1 minus 3, which is -4. So you have a vertex at 1, -4. Next, let us find the x-intercepts. So the x-intercept can be found by setting f of x equal to 0 and solving for x. So you end up with x squared minus 2x minus 3 equals 0, and then you have to solve this. Your choices would be the quadratic formula or factoring. If you chose to factor, this will factor into x minus 3 times x plus 1 equal 0. If you chose to use the quadratic formula, then you would set it up as follows. So for the quadratic formula, remember it's -b plus or minus the square root of b squared minus 4ac all divided by 2a, and this is what x is equal to. So you would plug in the a and the b and the c, and you will work it out if you want to do it the quadratic formula way. Either way, you'll end up with x being equal to 3 as well as -1. So these are your x-intercepts. So now let us do our y-intercepts. Or actually, excuse me, let me find the axis of symmetry. So the axis of symmetry is going to be at the line x equals 1. Because remember, it's always at x equals h. So this is x equals 1. Now we can do our y-intercept. And the y-intercept means, well, replace x with 0 and solve for y. So you end up with y equals 0 squared minus 2 times 0 minus 3, which is -3. So your y-intercept is -3. And then the last two things we need to do here are the domain and the range. Well, the domain, like before, is all reals. There's no restriction. And the range comes from the vertex, which is at -1, -4. And now a is positive here, which means this parabola opens up. So it opens up, and that vertex is right here, that 1, -4. So the smallest that y can be is -4, and we include it, and it goes all the way up to infinity. Alright, the minimum and maximum value of a quadratic function. Consider the quadratic function f of x equals ax squared plus bx plus c. If a is positive, then f has a minimum that occurs at x equals negative b over 2a, and this minimum value is f of negative b over 2a. So let's break this down. If a is positive, then my parabola opens up, which means the vertex is the lowest spot, so that's where the minimum comes from. And then it says it occurs at x equals negative b over 2a. Well, this is the x coordinate of the vertex. And the minimum value is found at f of this. Well, this is the y coordinate of the vertex. So these are all pieces that we know how to find already. We're just breaking it down further so we can understand the concepts. If a is less than 0, so I have an inverted bowl, means it opens downward. And f has a maximum because the vertex is the highest point. And the x equals negative b over 2a, again, that's the x coordinate from the vertex. And y equaling, and the maximum value being f of negative b over 2a, well, that is the y coordinate. So in each case, the value x equals negative b over 2a gives the location of the minimum or maximum value. So this, the x, gives the location. And the value of y, or f of negative b over 2a, gives the minimum or maximum value. So the x-coordinate tells us where is the location, where is it at, and the y tells us the actual value. All right, let's go in our books to page 343. Let's look at number 41. So 41 says, an equation of a quadratic function is given. And part A says, determine without graphing whether the function has a minimum value or a maximum value. Part B says, find the minimum or maximum value and determine where it occurs. And part C says, identify the function's domain and range. So 41 is negative 4x squared plus 8x minus 3. And part A is determine without graphing whether the function has a minimum or a maximum. So how will you do this? You need to know, does it open? So does the graph open up or down? And of course that's determined by the A. So A is equal to negative 4, which is less than 0. So this opens down. So it opens down, so it should have a shape like this, which means we actually have a maximum. Part B says, find the minimum or maximum value and determine where it occurs. So this is basically saying, find the vertex. So let's find the vertex of this function. So let's identify the A, the B, and the C. A is going to be negative 4, B is going to be 8, and C is going to be negative 3. So then the x-coordinate is found by doing negative 8 divided by 2 times negative 4, which is going to be 1. And then to get the y, we just take the 1 and plug it back into the function. So negative 4 times 1 squared plus 8 times 1 minus 3. So y equals 1 as well. 1. So you have a vertex at the point 1, 1. So the maximum value occurs, the maximum value is 1, and the location is at x equals 1. And then part C is determine the domain and the range. Well, like always, this domain, since I have no restrictions, is going to be all real, so from negative infinity to infinity. And the range, well, I know this graph opens down. The vertex is the highest point, and the range deals with the y. So the highest that this thing can get here is 1, and the smallest it can be is negative infinity. So the range goes from negative infinity to 1. And use bracket on 1 because you're including it. Okay, this concludes our video for 3.1. Let me know if you have any questions.